I want to kind of try and paint a big picture of what we do mapping here at Google and its context within lots of the activities that go on here. And in some ways, what we do with mapping is very obvious. In other ways, less so. And if I was going to sort of subtitle my talk, it would be this. I like buzzwords and I like pictures of rockets. So why geospatial technology will be the rocket fuel for the Internet of Things? Show of hands, who's heard of the Internet of Things so far? Most people. It's one of those kind of buzzwords that's flying around at the moment. Internet of Things, big data, smart cities, these are the things that we're all talking about. And they are actually probably all linked as topics. And part of that linking, I think, is underlying a lot of the interest in the Internet of Things, this idea of everything on the Internet being connected, is the fact that everything happens somewhere. And the somewhere is the piece that we are most interested in. But I'm going to come back to this a little bit towards the end of the presentation. So let me start off with the basic premise of what we do, and that is to try and create a map of everywhere. And here we are in London, an area that we're probably all very familiar with, and we take for granted that we'll be able to get access to a map like this very easily now on the web, on our mobile devices. It's ambient, as the title said, ambient maps. It's something that we can just get access to really, really easily. It hasn't always been like this. Another show of hands, who remembers life before Google Maps? Sad, wasn't it? It was difficult. It was hard to get maps. And in many ways, you know, we kind of take it now for granted that we can get a map like this and we can interact with it. And interacting is the kind of fun bit. But we can also get maps of not just London. We can get maps of, anyone recognize where that might be? Windhoek. Windhoek is the capital of Namibia. And you'll see the map, in detail terms, looks very similar. It's got the same amount of content. We have street names, we have the addresses and locations of schools, businesses, railway stations, admittedly much smaller Windhoek, but that same level of detail. All the maps I'm showing you are the same scale. They show you the same content. Now, part of what we do at Google is to try to make information universally accessible. And universally, in a mapping sense, means we need maps of pretty much everywhere. Okay, so that's Windhoek. Here's somewhere that we may hear a bit more of over the summer. This is Manaus in Brazil. This is where England will be playing their qualifying games in the World Cup. So you won't hear about this place for very long. But when we are hearing about it, this is what it looks like in Google Maps. And again, you had that same level of detail. We've gone from Windhoek, Namibia, Brazil, much bigger country. I'm going to go to an extreme now, and this is somewhere I'd love to visit. I haven't actually yet, despite what the guys might say. Anyone recognize where this is? Real geeky question, this one. No. This is Tuvalu. Tuvalu is a Pacific island. It's about the 220th smallest country. There are 249 countries. In size order, Tuvalu comes in at about 226. It's about 20 square kilometers, about the same size as Kensington and Chelsea. Has a population of 10,000 people. Its claim for fame, I suppose, or claim for infamy, is that the highest point in Tuvalu is only 5 meters above sea level. So with climate change happening, this is probably the first country that will disappear as a result of climate change. Nevertheless, we have gone and we've collected the same information in Tuvalu as we have in London and in Windhoek and in Manaus. It has to be universal. We have to have that information everywhere. And you know, lots of people claim that we have great maps of the world. We really do have great maps of the world now, perhaps for the very first time. And maps are now more accessible than they've ever been. More people get access to mapping than ever before. But it's more than just creating map tiles. Now, we spent the first sort of 5 or 6 years of our existence creating map tiles, little squares that represented the world in various scales, various resolutions. And we spent a lot of time and effort building those. But of course, to make this information really useful, it has to be more than just the map itself. We need to be able to interact with the map. We need to be able to search. We need to be able to get directions. A lot of what makes a digital map different to a paper map is the ability to interact with it, to ask the map questions. And I know this is one of the key differentiators that makes digital mapping so much more useful. So, sticking with Tuvalu, I can say, okay, well, I don't just want to see the traditional cartographic map. I want to see, in this case, satellite imagery. We begin to get a sense of what this Pacific island might look like. You can see the nice shallow waters there. You can see most of Tuvalu is a runway at the airfield there. If I really want to get a sense of what the place is like, though, I want to be there at a kind of a human scale, if I was standing on the street corner, and that's where Street View comes in. And here we have Street View of Tuvalu, so I can interact with this picture and have a look around. Remember, this is, the 226th country of the world, tiny, 10,000 population. Still, it's important to have imagery like this to get that sense of what the place is like. And of course, I want to be able to search. I want to be able to find out what's there. So here I am searching for a hotel in Tuvalu. Let's imagine that I was going to go and stay in Tuvalu. I wanted to find out about this hotel. There were a number of photographs available. There is a review. Turns out this is the only hotel in the country, so this would be the hotel I would choose, probably. Despite, well, actually, 4 out of 5 stars isn't so bad for the one hotel on the island. I might go and stay there. So beyond that, beyond finding a place, now I want to have a look around. I want to find out what's around me. This is where digital mapping is really different. I want to be able to, as it says here, search nearby that particular hotel on Tuvalu. What else is there around? And obviously, this is an extreme example. In Tuvalu, there isn't very much else around. But obviously, if I was in London or New York or anywhere else, I'd have much more to do. But I can see search nearby, search for maybe a nearby restaurant. Again, I can find out information about that particular restaurant, its opening hours, telephone number, and the world's simplest driving directions to get you to this hotel. So here I am from the hotel. I basically drive along, I make one turn, and I arrive at the restaurant. And I could, if there was any traffic on Tuvalu, show you the traffic jams that might be there. We're doing that by sensing the very few mobile phones on Tuvalu, but there are lots of mobile phones elsewhere that give us that real sense of traffic information in real time anywhere. And it even gives me an option of taking a different route to get to the restaurant. The key point I'm making here is, okay, kind of an extreme example using Tuvalu, but that capability to search locally, to get driving directions is global. It happens everywhere. We have that capability wherever we travel on the planet. And that's something that we've never really had. And it allows us to travel much more comfortably, much more confidently than we've ever done before. And if we're business owners and if we are responsible for making services available to our citizens, that platform, that underlying capability is there for us all to make use of. Okay, let's now kind of take a little bit of a leap of imagination. Let's say I've gone to Tuvalu, I'm staying in this hotel, I'm eating at this particular restaurant. Someone asks me, Ed, what do you do? And I say, I'm Google's Geospatial Technologist. And they go, oh, that's an impressive job title. Let me give you a presentation about what I do. I open up my bag, and I find I've forgotten my dongle. If you are a road warrior like myself, and you have an Apple computer, like this one here, you'll find they all have these little white plastic dongles attached to them, because Apple, in their wisdom, have decided to use this mini DisplayPort thing that no one else uses. So you end up having to have one of these dongles. And I'm paranoid about losing my dongle, but let's just assume that on my trip to Tuvalu, I've lost my dongle. I can't give the presentation. I need to find the nearest Apple store to Tuvalu. Turns out the nearest Apple store is in Hawaii. Not a problem, Google Maps can give me directions to Hawaii. It will take me 19 hours and 45 minutes to fly there. Here's the route that I would take. Fiji Airways most of the way, little propeller plane, 2-hour flight, and then another propeller plane, half-hour flight, then a jet plane, 4-hour, 40-minute flight, and then another jet plane, 3-hour, 15-minute flight. God, I wish they'd just have a normal VGA connector onto their laptop, but never mind. I'm going to go from Tuvalu to Hawaii. Fantastic. And I just want to check that when I get to Hawaii, Honolulu International Airport, I can get to the Apple store in the mall there, and I can take public transport. That's great. I won't have to hire a car. Okay, so I book my plane ticket. It only flies on a Tuesday, so I'll have to come back on another day, but we fly on that Tuesday. I arrive at Honolulu International Airport. I pull out my mobile phone now, and I can pull up a map of the inside of the airport to work out where the bank is, to get to the ATM to get some dollars so I can go and buy my adapter. Maps of the indoors are going to be a huge growth area in our industry. We spend about 70% of our lives indoors, but most of the traditional mapping technology that we've used in the past stops working when you go indoors. So actually collecting the indoor floor plans and getting the capability to map indoors is going to be one of those areas that we'll all put a lot of effort into, because there's a huge benefit on being able to find our way around when we're indoors. Okay, fabulous. Traveling in on the bus, I can work out where I am at any particular point on that route, see how long it's going to take. It'll even tell me what the fare is, $2.50. That's quite reasonable, I think, compared to Transport for London prices. Oh, sorry, Phil. And look at the view. Look at the view. No, sorry, I can't do anything about that. And eventually I end up in the shopping mall and I can get directions on foot actually to the Apple store to buy my dongle so I can go back and give that presentation. Okay, a rather convoluted story, but demonstrates that we're talking about more than just map tiles here. We're talking about this ability to interact in real time, to bring lots of different data sets together that use geographic information as a sort of a backdrop. And it's something that, okay, this is kind of an extreme example, but you can see, and you probably do, start to use this information every day because maps are answering particular questions that you might have. That's how we've moved beyond this idea of there just being map tiles. This is something we now interact with. And it means a lot of the effort to create this content goes on behind the scenes, often not exposed in the sense that the map might look different. A lot of the information actually happens behind the scenes. It's only when you start asking questions that information becomes available. And that brings me to, I think, what's going to be one of the other things that's changed maybe in the last year or two in the way that we think about mapping. In cartography, it's always been the case that less is more. When you make a map, what you do is you choose what not to show. A map is always a simplification of reality. You make a design choice to say, these are things that are not important to show in communicating this particular message. Now, you could argue that we've had a bit of a kind of an arms race between all these mapping companies to say, let's throw as much information as possible on the map just to prove that we've got it, show how cool we are, look how much content that we have. But actually, that's not what good maps are about. You probably recognize this is the original drawing that was done for the tube map. And you can see the kind of the iconic idea here of taking what is quite complex reality and simplifying it down to something that is more usable. The great power of the tube map is not what it shows, but what it doesn't show. And we're beginning to take that approach with our cartography as well, to say, well, when we show maps, let's choose what we show for particular tasks. Now, this might not be very clear to show, but I'll do my best. So this is the new version of Google Maps that probably many of you will have now seen. And it takes advantage of a huge change in the capability of web browsers. Basically, what we're doing is we're displaying vector data, lines rather than map tiles, that are rendered in real time by the browser itself. So the browser is actually controlling what you see on the map, which means the map itself can be very dynamic. It can change depending upon what you're doing in any particular point in time. Now, this is a very general map. It's just a map of the area around South Kensington, around the museums. Now, as soon as I click on something on this map, the map itself will change the way it's displayed. I'm going to click particularly on the Science Museum. Now, watch very carefully, see if you can see how the map changes. Obviously, this panel appears. It gives me lots of information about the Science Museum. But the map itself, underneath, also changed. Now, I'll go back and forward. Now, watch very carefully how the map changes the way it's displayed. You'll see, go back again. Watch these roads here. They fade because they're not as relevant if you're going to the Science Museum than Exhibition Road is. You'll see hotels appear when I click on the Science Museum that are nearby because they are now relevant to this particular map. So this has become, if you like, a Science Museum map. It's a map that's specific to someone visiting the Science Museum. The underlying cartography has changed for that particular task. Now, that's something that's quite new, it's quite radical, and it's something that we're continually working on, continually iterating to try to make the maps more usable, more user-friendly by making those subtle changes to make the maps useful for the particular task in hand. So showing less rather than showing more. Now, that obviously becomes really important when you move beyond the traditional map, traditional cartography as a way of communicating information. A lot of that same information about the map of South Kensington is held in databases that are accessible to someone using wearable computing, using Google Glass, for example. When you're using Google Glass, how you represent geographic information has to be very different. We have to take a lot of that content and just not show it. But we can do that because Google Glass has the power of context. It knows who the wearer is. It knows where the wearer is at any particular point in time. So we can display information very differently. So here I am. This is the street that I live in southwest London. I can switch on my Google Glass. It tells me, without me asking particularly, what the local weather conditions are. So it was a relatively nice day, maximum temperature 17, minimum 0, no chance of rain, 16 degrees at that particular point. Now I was going to go just to local shops. So I ask for directions using voice interface, and it tells me, okay, because my preference set is to use public transport, here's the route. It's going to take me 8 minutes. I need to walk a little bit to a railway station, and that's the route I'm going to take. Now look how abstract a map representation that is. It's saying you need to walk a bit, then you're going to go on the train. We're doing a lot of work to understand, well, how do you cognitively communicate those sorts of messages to people where you wouldn't use a traditional map? You can, of course, use a map, but it has to be more simplified. When you're looking at that as you're walking along, you can't have a lot of content displayed. So it's abstracted to just the piece of information that you need. And then as you start walking along, you're given particular cues at particular points along the journey. It's the same content that we were displaying before, but now abstracted to a few key messages as we move along. On the other extreme is when we have huge volumes of data that we want to display. This is some work that I've been closely associated with. We're working to look at the impact of deforestation. This is Global Forest Watch, which is a kind of mass scientific program to try and, in almost real time, monitor deforestation as it happens. So the little pink dots that you see around the globe are areas where deforestation has occurred. that's coming from satellite imagery that is being processed on a daily basis and being updated to this particular site. And what's interesting is this is clearly a global issue. You can zoom in at any level of detail, and this is petabytes of information we're handling here. I can zoom in and see detail, and here, this is really interesting, you can see that there is both loss and gain happening perhaps where you might not expect it. So here you see in Northern England and in Scotland, actually there's a fair amount of gain in woodland, gain in forestry happening because of the various tax breaks that have been introduced over the last few years. But to be able to go from that global view and then zoom down to any particular site in this way is a huge advance that we've never been able to really do previously. Here's some information that is obviously quite newsworthy. This is the Flight Radar website that uses Google Maps to display the location of aircraft from their ADS-B transponders. Now, on Flight 370, it was their transponder that was switched off that meant that this system completely broke and we could no longer track the airliner. But at any point now in real time, pretty much anywhere in the world, I can go and I can track aircraft as they move around. A capability that is really interesting when it's applied to aviation, but these could be vehicles that are delivering goods. They could be people moving around the city. We can track information in real time. And just in case you were thinking that, unfortunately Malaysian Airline 370 was a one-off, these are at least 20 aircraft over the past 40 years that have gone missing and still haven't been found. So here's a map that's telling a story. And this, again, is another use of mapping that is really interesting and is developing. The idea of the map as being part of a narrative, of explaining a story to people. You've seen lots of maps probably around 370 over the last few weeks. Many of them are not particularly good, I must say. But maps like this are very powerful. They can communicate a message more quickly than many, many lines of text. Or we can look at perhaps quite complex data, but when displayed spatially, we can see patterns emerging. This is data that comes from Eurostat, and it's about European broadband penetration. And what's interesting here from the UK's point of view is you can see, there's a distribution, it seems, from east to west, where the further west you get, the better connectivity you get. And what's quite positive to see here, the green line represents the European average, the blue line represents the UK. So at some point in 2010, we went above the European average in terms of broadband penetration. So again, a way of communicating or seeing insights from data when displayed in a map. Okay, so that's maps of everywhere. Now maps for everybody. Again, here's the new version of Google Maps. This is now somewhere different. This is New York, Manhattan. You can see from this map initially that it's kind of generic because no one has signed in. You can see it says sign in there. As you know, if you choose to sign in, and again it's a choice, if you choose to sign in, the map starts to become customized to you as an individual, based on the places that you visited, places that your friends have visited, things that you're interested in. So if I log in and now look at the same area, the map again has changed very subtly, and I'll flick between the two and you'll see those changes. The customized map, my map, will have the hotels that I've stayed at, restaurants that I might have visited. This is my son's favorite location on the planet. It's a place called the Donut Pub. You can guess what they sell at the Donut Pub. But it's my map now. And basically, if you've logged in, you will see your own map of any particular location you're looking at. It means now that every map that we create is specific to an individual user, or no two maps are the same. Again, that's one of those sudden changes that have gone from where it used to be with paper maps, everyone saw the same content. Now, with digital maps, the content changes. if I know a little bit of information about you, if you're sharing information, I can start to provide information to you that's more relevant. Again, choose to share some information with me, for example, the route that you might commute, and then on your mobile device, I can warn you and say, okay, there's roadworks on your normal commute, it's going to take you a little bit longer. And that information is coming from other users. It's using people who are using the Waze application to tell you that there are roadworks on that route that you're particularly used to using. You haven't had to ask for that information. It's displayed because you shared the fact that you use that particular route. That idea of having information that is very contextual, very personal to you, becomes all the more important when your display device is something as small as a watch face. And you've probably heard of an initiative we have here at Google called Android Wear, which is developing technology to display information on wearable devices, for example, watches. So here again, that same sort of information presented to you in a very simple form, saying, okay, it's going to take you 35 minutes to get to work this morning, based on real-time traffic conditions, based on the fact that we know where your home is, where you work. You've shared that information with us. I now want to show you a video that takes us now really to that kind of idea of the Internet of Things, because we're now going to look at a map of everything. So we've gone from everywhere, maps of everybody, now going to everything. So if we could show that video now, please.
My name is Johnny Lee, and I work in the Advanced Technology and Projects Group at Google. Our small team here, based in California, has been working with universities, research labs, and industrial partners to harvest the last 10 years of research in robotics and computer vision to concentrate that technology into a very unique mobile phone. We are physical beings that live in a 3D world, yet mobile devices today assume that the physical world ends at the boundaries of the screen. Our goal is to give mobile devices a human-scale understanding of space and motion.
This is going to allow people to interact with their environment in just a fundamentally different way. We can prototype in a couple hours something that would take us months or even years before, because we didn't have this technology readily available.
What happens if you have all of these pieces in a phone? How does that change what a phone is?
We have created a prototype phone containing highly customized hardware and software designed to allow the phone to track its motion in full 3D in real time as you hold it. These sensors make over 250,000 3D measurements every single second, updating the position and rotation of the phone, fusing this information into a single 3D model of the environment.
We have a problem called navigation indoors, and it's a solution to that problem.
It tracks your position as you go around the world, and it also makes a map of that.
Imagine that you scan a small section of your living room and then are able to generate a little game world in it. I don't know of any other controller or gaming device that can do that at the moment.
Putting all this together, they pulled in experts from all around the world and got them all working on the same project.
Those are very high caliber people. Why? It's very simple. I think actually people believe in the vision.
Localization and mapping is there on your phone and you just use it. It's this ability to follow in other people's footsteps.
And we can also benefit from what we do for the project back for the open source community.
Use it for visually impaired, give them auditory cues on where they're going.
You know, being able to map your home. Oh, check out, let me see how this furniture looks in my room.
Virtual windows to sort of different worlds. I mean, the possibilities are really endless.
Over the next few months, we will be distributing dev kits to software developers to develop applications and algorithms on top of this platform. We are just in the beginning, and we know there is a lot more work to do, but we are excited about where it is going to go. The future is awesome, and we believe we can build it faster together.
Okay, so that's Project Tango, and you can see that's some way off in the future, that becoming a standard operational sort of device. But you can see the potential of being able to map indoors, to be able to map those spaces that we've not been able to do before, to interact with the devices around us. We're living in worlds now that are increasingly networked of devices as well as people. I passed through my home this morning on my way into the office and just did a quick survey of the number of Wi-Fi devices I had connected to the internet at home. I don't know how many you might have. Think about this. When you go home, have a count round, log into your router and find out. I have 47 devices at home that are connected to the internet. Okay, maybe I'm a bit extreme. But 47 devices, each of which has an IP address, can interact potentially with each other to do interesting things. This is where I really get my geek cred, I think. These are my Christmas tree lights that were connected this year to the internet for the first time. Why, you might ask, Ed, have you connected your Christmas tree lights to the internet? Well, obviously for my geek credentials, but actually what happened was I connected them to the National Weather Service in the United States that has a great website that tells you the sunset, sunrise time of anywhere on the planet. So my Christmas tree lights would always go on at 10 minutes past sunset for every day during the month of December, and would switch off at a random time between 10:30 and 11 every night, just because I could. All right, not particularly useful, you might say. Okay, fair enough. But imagine more useful applications of devices that are connected online and that can interact with their environment around them. You probably heard about Nest. Nest is a company that we acquired last year that make basically two devices. You can buy these smoke detectors here. You can get these in John Lewis, for example, and an intelligent thermostat. Both of these connect to your Wi-Fi network at home, and they work in slightly different ways. The Nest is literally just a thermostat, and it learns your behavior from the way that you interact with it. When you turn the heating on or off, mostly the heating. You look at online, this is really funny, you look online for pictures of Nest, and you'll always find it blue. When it's blue, it's working in air conditioning mode. In the UK, you will never see it blue. It will always be this orange in warming mode. So it watches when you turn the heating on and off and begins to see patterns in your behavior. You know, what time do you normally get home? In the evening? When do you switch the heating on the weekends? What temperature do you have? And starts to learn your behaviors and starts to then try to reduce power consumption when you're not around automatically. The smoke alarm is quite clever in that it monitors when you're actually in the house. As you walk past the smoke detector, as it's in the ceiling, and I've got one of these at home, the light just flashes to know that you've gone past and to just check the system is working. And it, again, interacts with the environment around it. Now, it's early days for these devices, but there's huge potential in devices that we have around our house that are more intelligent, that can interact with the environment and to make changes based upon the information they're sensing. Oh no, not the internet fridge. Everyone, whenever you do an Internet of Things presentation, we all talk about the internet connected fridge. And for a long time, you know, this was the holy grail of the Internet of Things. You know, Samsung would desperately try to sell you the fridge that had, like, you know, in effect, an iPad stuck on the door, and it will give you recipes. And supposedly there are fridges that could monitor your usage of orange juice or milk and potentially phone out to Ocado when you needed more milk and actually get it delivered without you having any part in the process. And my wife was so excited about this, saying, you know, I don't have to go online with Ocado anymore. The fridge will order everything. I was less excited about this potential. But there is real benefit in this. And if you think about it, it's associated with, again, a very simple concept of energy consumption. Fridges, it appears, have to assume during their operation that you're going to open the door. Because when you open the door, obviously the cooling is less efficient. So fridges in a kind of standard mode of operation are assuming that at any point you're going to open the door, and they have to maintain a level of refrigeration for that happening. Most of the time, you're not home. during the day, you're not likely to open the fridge door. During those times, there's no reason why, if you had an intelligent fridge, it would reduce power consumption to say, well, I know no one's going to open the door for the next 6 hours. I can reduce the refrigeration amount by up to 5–10% during that period of time, knowing that no one is going to open the door, because it knows that no one's home, because it could identify whereabouts you are, because it's connected to the Internet of Things. That's a simple example, but a very practical one. A one that if you scaled it up, every fridge in every kitchen in the UK with a 10% energy saving, that would be huge. And that's a real benefit of the Internet of Things. Now, if you think about the fridge, and you multiply it by every home, and you think about all the other devices that we kind of interact with, that's really what becomes a smart city. A smart city is just the Internet of Things at a different scale. It's talking about the things that we interact with networked together, working intelligently based on information that is around them, that's geospatial, that is located around them. So that's where this idea of geospatial technology being the rocket fuel behind the Internet of Things comes from. This internet fridge would work, and it will work within the next year or so, because of that connectivity, of knowing where its owners are. If its owners aren't home, it doesn't need to have as much power to do the cooling because it knows you're not going to open the door. Let me finish with some final thoughts. I like this concept of geo-DNA. We all know the idea of DNA. DNA, those building blocks that we all share, that every element, every molecule in every living thing shares. And much of that DNA is similar across most living things. But the DNA is often hidden, is invisible. The fact that we're sharing a lot of common DNA isn't necessarily obvious to us. From a products and services point of view for us at Google, and probably for most of your organizations in the things that you do, you will have a kind of a common geo-DNA in everything that you do. In almost every product that Google creates, be it Google Search, be it Hangouts, Google Docs, there's a little piece of geo-DNA there, because lots of the information that we're dealing with has a location attached to it. So what we do often is quite visible in terms of Google Maps, but a lot of the stuff that's really important to us is invisible. It sits behind the scenes as part of that kind of DNA. Think in those broad terms about the activities that you do, the activities that we do. What's that element of geospatial, the element of location that might be in many parts of what you do? Might not be obvious, might not be really visible. But think of those connections, looking at things from a slightly different perspective. That idea of the internet fridge. You wouldn't think that the location of its owners as such, the other people it shares a household with, would be important in terms of energy consumption, but it really is. The second piece, and obviously this leads on to what the guys are going to be talking about later on today, is stand on our shoulders. And what I mean by that is make use of the platform that we've created. We've built a platform that we use ourselves as part of that GeoDNA. It's elements within lots of different services. But much of what we have built in terms of the data, in terms of the ability to interact with it, the services that we've built, are available to you via the APIs, via the enterprise services. You don't have to start from the ground up anymore. You can build on the platform that we have built and add the little element that makes the difference to your particular user need for your particular requirement. So remember, you're not starting from scratch. You're not starting from where you might have started 5 or 6 years ago. It's a much easier position to start on. And you can get working much more quickly than was ever possible before. And we're willing and we want to work with you to do that, to deliver on top of that platform. Okay, that's all I really wanted to say. I hope I've kept you reasonably entertained. Thank you very much for listening.